Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to be talking about the circle, and it's been a while. We kind of introduced the circle a while ago in chapter 2, but now we are going to launch out into chapter 3 and really kind of start talking about the circle in depth. This is on page 132. Page 132. Lesson 3.1, we're going to start talking about arcs. Now, what does that mean? What does an arc mean? Well, arc, A-R-C-S, is a part of a circle. And I think we've kind of already talked about what that arc is. It's part of the outside of the circle, the curved part of the circle. So we're going to talk a little bit more in depth today in this lesson about those arcs. The first thing that I want to do, though, is I kind of want to back up. I want to go through some things that are, I'm going to call them general circle properties. You can look right here on the screen. General circle properties. What does that mean? These are things that are true about every single circle, no matter how big, how small, no matter anything about a circle. These are always going to be true about circles. So most of them are pretty basic, but I want to go through them real quick before we get into the rest of the lesson. All right, number one. All radii and diameters of the same or congruent circles are equal. Now, if you're looking in your book, it's on page 132, page 132, and you're going to see this information. I wrote it a little bit differently than the book. I don't want to copy down exactly what the book is saying here. I want to kind of give it to you in my own words. That way you can hopefully kind of connect the two, whether it's me or you reading the book, and kind of connect the two and maybe just really learn some things here about the circle. All radii. What's a radii? Well, multiple radiuses. All right, radiuses is not a word. A radius goes from the center point to the circle. Okay, so I'll put one up here. Put just a little fake little circle right here. It's not a real circle. If you go from the center to the edge of the circle, that would be a radius. So what is a radii? A radii is when you have multiple radiuses. Okay, so if you have more than one radius, it's a radii. Now, also diameters are included here. So if I have a circle, again, I'm just drawing a circle. It's not a real circle, okay? I'm just drawing a little quick shape. If I keep drawing these little radiuses out from the center, okay, every one of these radiuses is going to be the same. Let's say that they're 3 inches. That one's 3 inches, that one's 3 inches, that one's 3 inches, that one's 3 inches. They're all 3 inches, okay? Just like the same thing would be true if they were diameters. So if I have a diameter in there, let's draw a diameter. Diameter, remember, goes from the center of the circle all the way through, touches the circle again. If the radius is 6, then if the radius is 3, the diameter is going to be 6. Now, if I have another circle, check this out. This is kind of crazy when you think about it. If I have another circle, and I don't really have room to draw another circle, but I'll try to draw one. It's a little too big. I don't know. There we go. You know what? I'm just trying my best here. All right, so we put another one here, and let's say that it is also 6. What do we know about those two circles? Well, they're congruent. They're the same size and the same shape, and that's based on the radius or the diameter, either one. Okay. Number 2. A circle is always congruent if the radii are congruent. That's almost like the converse of number 1. Circles with equal radii are congruent. So if I have 5 circles, they all have a radius of 3, then they're all going to be congruent circles. Okay, so I could as many as I want to put on there. And then number 3, if the center point of a congruent circle coincides, so if you have 2 congruent circles or 2 circles that are the same and they coincide, what does that mean? You should remember that from triangles. If something coincides, then it is right on top of the other one. So if you take 2 congruent circles and you put their center point on top of each other, then the whole circle coincides. In other words, if I have two circles, okay, and I take this and move it, basically move it over here, and I take this center point and I move this center point right here, what happens? Well, I have my circle with my center point, and then my other circle sits right on top of it, okay? In other words, it's going to occupy the same exact space. The center point will be on the center point, and the circle will be on the circle. And that's the idea there of number 3. Number 4, depending on their distance to the center, points can be in, on, or outside the circle. So depending on their distance to the center point. So again, here's our little circle here, and we can make a center point here. So let's change our color. We'll put a pink dot. So there's 3 relationships that a point can have. A point can be inside the circle, okay? A point can be on the circle, or a point can be outside the circle. There's really no other relationship. I guess you could say, well, the point can be on the point. Yes, it's still inside the circle, okay? So yes, the point could be on the point. The point could be the center point. But that center point is still inside the circle. So inside, on, or outside. Those are the 3 relationships. So right here it says points can be in, on, or outside. Those are your 3 relationships of points to a circle. And then the last one, or actually I have 2 more. Number 5, a straight line with a point in the circle cuts the circle in exactly 2 points. So let's go back to this one. So here's my original circle right here. And it says a straight line with a point in the circle. So let's put a point in the circle. And now we're going to make a straight line from that point. And it doesn't matter, you just want to make sure it from that point. Now look, every time you do that, it is going to touch the circle once here and once here. 2 times. It has to touch the circle 2 times. So if you have a point inside the circle, it doesn't matter where it is. Let's put one over here. And now I take a line, and then it's going to touch 2 times. It's touching here, and it's touching here. Okay? So anytime that you have a point in the circle, and you connect a straight line to it, it will cut the circle in 2 points. It will touch the circle in 2 points. It can't touch it more than 2 points, and it cannot touch it less than 2 points. I guess unless you had a line segment in which, it ended somewhere. But we're talking about a straight line. We're not talking about line segments. Next and last. Number 6. With a given point and a given radius, only one circle can be drawn. So in other words, let's take a given point. So here is my given point. Here is my given point, and I can say, okay, my radius is 3 inches. Well, I can only draw one circle with that. So basically, I can only draw a circle with that radius, and it's not perfect, but, deal with it. I can't draw any other circles. So if I have a point and a given line, 3 inches, 5 inches, 10 inches, I can only draw one circle. Okay, so it has to be a point, radius, and then the circle around it. You can only do it one time only. Now again, most of those things were pretty easy, pretty self-explanatory there. I just kind of wanted to show you some of those things so that when we talk about this, you'll have these things in your mind. And those were all on page 132 if you want to take a look there. The next section on 132 is about arcs. So I want to take just a few minutes here in the video, just kind of wrap up this video and talk just a little bit about arcs. What is an arc? Well, an arc is the curve of the circle. And not just the curve of the circle, it's a part, okay? It's a section of the curve of the circle. So here, AB is an arc, and you put like a little arc over top of the arc. You don't put a straight line. Okay, you put an arc line, and that tells you that it's dealing with the arc. What if I put a straight line on that? Well, if I put a straight line on it, then it's dealing with this straight line. Okay, not talking about the arc, then it's talking about the line. So be very careful with that, that if you're talking about an arc, you put an arc on top of your AB. All right, so what if, let me just talk about this first. This is the first thing it talks about in the book, and this is on page 132. It talks about congruent arcs. They are arcs that can be made to coincide. Like, let's say you have one arc here and one arc here. If I can take those arcs and I can put them on top of each other, or in other words, if they coincide, then they're equal or they're congruent. And we should have that down by now. We should know what congruent means. We've been talking about it long enough, especially with triangles, and then with squares and rectangles and quadrilaterals, things like that. So congruent means they can be made to coincide. So that would be congruent arcs. All right, now let's look at some different arcs. The first arc that I want to show you is arc AB. This is the one that we were just talking about. So let's talk about AB. This guy right here. This would be what's called a minor arc. A minor arc. Minor arcs are arcs that are less than 180. So any arc that's less than 180, a semicircle. Okay, what's a semicircle? AC, arc AC is a semicircle. Okay, what does that mean? It means that it's 180 degrees. Okay, remember the whole circle is 360, but we're talking about just this arc right here, half of the arc. If the diameter is cutting it in half, then we have a semicircle. AC, this one right here, is a semicircle. All right, and then if we go, now this is interesting. So what is a major arc? Well, if AB is a minor arc, I want to show you something. AB, again AB, going this way can be a major arc. So minor is, we'll write this less, let me write the less than sign. So less than 180. Okay, and a major arc is greater than 180. Okay, and then so the semicircle would be equal to 180. Okay, so minor arc is less than 180, semicircle equals 180, major arc is greater than 180. Really the only other concept here that this chapter wants you to know is this concept right here. Let me erase this line, and let's kind of go to, instead of now talking about the arcs, let's talk about this angle right here that creates the arc. Okay, so this angle that creates the arc, look, the vertex is the center point. So this would be called a central angle. Central angles have their vertex on the center point. Okay, so that vertex is right there on the center point, thus making it a central angle. Okay. This is a little bit of technical terminology here, right at the very bottom of page 132. It uses the word that says an angle is said to intercept the arc. So let me write that. Angles intercept the arc. And we're going to use that word quite a bit right there. So that is an important word. The angle intercepts the arc, not intersect. Okay, it intercepts. The next terminology there is that it says arcs, and this is on the bottom of page 132. Arcs subtend or determine the angle. All right, so when we're talking about the arc, and I'm going to go back to this in just a second. That word is super important right there, subtend. You're going to see it all the time. And then every once in a while, you'll see the word determine. But most of the time in this book, and then in geometry in general, you're going to see the word subtend. So arcs subtend the angle. Angles intercept the arc. So let's go back and look at this. Let me erase some of this stuff so that you can see it a little bit better. So we'll go back to the central angle here. And if we're talking about the angle, okay, if we're saying, okay, this angle, notice how the angle defines the arc, right? It puts the border, it puts the limits on it. So there's a limit, B's a limit, and A's a limit, okay? Now that's interesting right there. The angle the angle intercepts the arc, okay? So what does that mean? The angle is like stopping the arc at those two points right there. It's intercepting. It's kind of like intersect. It's very close in nature to the same meaning. So it's intercepting right here. Okay. Basically, it limits the arc. The angle is what tells you how big the arc is. Now, look at this. The other one says arcs subtend the angle. So now if we're looking at this arc, okay, I want you to see something. Notice that the arc itself is also stopping at these 2 points. So the arc is telling the angle how big to be. The angle tells the arc how big it is, but also the arc tells the angle how big it is, how big it can open, okay? So the arc subtends the angle, but the angle intercepts the arc. It's a little bit of technical jargon, but as we go through the book, you're going to need to know the difference between those two. Angles intercept, arcs subtend, okay? This is the key right there. You need to know that. Angles intercept the arc, arcs subtend the angle. But you will need to know that for questions that you face in the book, for tests, for quizzes, and just for when I'm talking, I'm going to say, I'm going to use the word subtend and I'm going to use the word intercept, and you're going to have to figure out what that means. So focus on, when you hear the word intercept, you're focused on, okay, the angle is limiting the arc. When you hear the word subtend, you're thinking, oh, the arc is defining the angle. Okay, so angles define arcs. That's called interception. Arcs determine the angle. That's called subtending, or determine. Sometimes you will hear the word determine with that too. Okay. All right, that's all I have for you today. Hope you learned something today. If you missed anything there, if anything was unclear, just kind of rewind it real quick, watch it again. Hopefully you'll understand it. Work on some of these practice problems. They're really helpful to help you understand the lesson and to be able to apply the lesson so that you can do well on quizzes and tests that are coming up. All right, we'll see you later. Bye-bye.